Hello and welcome to IoT Builders. This is a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. This is episode 6 today, and we have Ali joining us from AWS to talk about smart territory framework and smart cities. And it should be a great discussion. So I am Dan Gross. I am a senior developer advocate at AWS, and I'm joined by my colleagues today. Let's see, who do we have on the line? Looks like Nenad and Alina and Syed have all joined.
So, hi everybody. Yeah, I'm Nenad, senior developer advocate, as well as my other teammates around IoT. So yeah, these things are happening now. It's like 6th episode, right?
Oh yeah, this is the 6th episode.
Awesome. Hey guys, you want to introduce yourselves?
Yeah. Hey, Alina.
Yeah. Hi Dan. Hi Nenad. Hi everyone. Thanks for tuning in. I'm Alina. I'm also a senior developer advocate, shocker, also for IoT, for connectivity and control services. And I am really happy to have Ali today with us and looking forward to this discussion.
Very cool. Very cool. And Syed?
Yeah, hi guys. Just like the rest of my colleagues, I'm the DA in the IoT service team. And glad to have you guys join us and listen to this.
Sounds great. All right, so how about we get started? It looks like Ali has joined us. So, hey, Ali, welcome. And why don't you tell us maybe a little bit about yourself? Let's see. I think you're still on mute. So if you can hear us, go ahead and unmute yourself. Are you there?
Can you hear me?
Hey.
Yeah.
Yeah,
okay.
we can hear you.
I was not able to let you hear anything. So hi everyone. Ali Benfattoum. So I'm a principal evangelist in the AWS IoT team. And I've been with AWS for almost 4 years and working on the IoT and smart cities industry for over 12 years. So thanks again for the invitation. This is a topic I'm very passionate about. So I could speak hours about IoT, smart cities, smart buildings. So if I speak too much, please interrupt me.
No worries. That's what the program's all about is having a discussion. So sounds great. Thanks a lot for taking the time and joining us. I think this is a really interesting topic, smart buildings, and this framework that you've developed, which is open source. Why don't we start a little bit about maybe your background? How did you get into IoT, and where did some of these concepts around smart buildings, smart cities, that sort of thing come from?
Yeah. So like I said, I've been working on smart cities, IoT, smart buildings for over 12 years. And so this is something I'm passionate about because IoT, it's so fascinating. And I mean, just thinking that devices can collect data, send data over the air, this is something I'm very interesting to learn about. And about these concepts of open source framework, the idea was to tackle the main challenges I see in these industries that I mentioned: smart buildings, smart cities, but mainly 3 challenges. So data silos, platform interoperability, and a coupling between data producers and data consumers. So that's why actually I started to design this framework, which is like you said, open source and also based on open source technology, open source and based on open standards.
That's really cool. So you talk about data producers, data consumers. How is that different than maybe some of the traditional ways about thinking about just a device? Like, we just have a device that sends data. Is this kind of more of an abstraction? Is that how you look at it?
Not really an abstraction, but more. I mean, let's take this simple example. When you sell a device, let's say you sell a smart device, and you control the device itself. You produce the device. You produce also you sell the application that consumes the data from this device. In that case, it's very simple because you know exactly how the device will communicate, what is the structure of the data that this device will send to your platform. You know how to store the data, and your application, your data consumer, that will be anything that would consume the data from this device, knows also how to consume the data, right? This is a kind of one-to-one relationship. In the domain that I mentioned, like smart cities, smart buildings, most of the time, customers, they need to work and orchestrate with an ecosystem of solutions and of solution providers as well. So they need to ingest data from heterogeneous sources, some using some connectivities like LoRaWAN, for example, others using other technologies, some operated by third-party providers. So if they had to, I would say, for each of these data producers producing their own data with their own format, with their own data structure, if they had to couple the consumers, they would have many interfaces to maintain, right? If you just take the example of, let's say you have 50 different sources of data, one for air quality, one for waste management with different sensors, some measuring the filling rate, some measuring the CO2, the temperature, and so on. And for each use case, you have multiple sensors. So let's say you have 50 different sources. And for consuming these sources, you have 10 different data consumers. That can be a mobile application, that can be an API, that can be a dashboard. This is quite small numbers for a city. Then for only 50 different sources and 10 different consumers, you would end with 500 interfaces to maintain, right? and this is not scalable. So that's one of the challenges I mentioned, which is decoupling data producers from data consumers, which brings me to another one of these challenges, which is data silos. So when we help customers, often they come with a technical challenge or a use case. Let's say I want to measure air quality, or I want to develop a waste management solutions. And we have plus 200 services within AWS, so they can build almost anything at scale. But the thing is that in this domain, like I said, you need to orchestrate multiple solutions. Have the sum of scalable solutions doesn't make a scalable platform, right? And this is
right.
quite the opposite. This is quite the opposite, actually. So this is why we designed this framework to have a core platform that you can leverage and plug your solutions over time. So, and you have shared capabilities like an IoT data lake to store all your data from different sources using a standardized data format. You can have also this central registry for all your devices, regardless the technology you use. So you won't have one registry for the LoRaWAN devices that you use with the solution provider, one registry for the devices that come from this solution that your startups or your solution providers provide, right? So you want to have a central registry to have this view of all your fleet of devices, regardless the technology or the operating model.
So that's the smart territory framework that's been developed.
Yeah.
Is the main point of that is to model your producers and consumers, and we're talking about, when we talk about smart territory, what are we talking about? You mentioned smart cities, smart buildings. It's really just any kind of footprint that you want to define, right?
Yeah, so that's actually why we decided to name this framework Smart Territory and not only smart cities, because I think it encompasses more geographical spaces. Because the challenges I mentioned, you can find them in a building, you can find them in a campus, you can find them in a country level, you can find them in a city, region, village, any place in which you have multiple stakeholders, in which you have an ecosystem of solutions, and you need to aggregate this data, collect this data to consume them efficiently. This actually applies. So we started with this smart city approach because, of course, when you design some technical capabilities, you also need to come with a story, with some I would say with some a story that is that resonates with a domain, but technically speaking, the components of the smart territory framework, the technical components, can be applied to agriculture, manufacturing, energy, any domain, like I said, in which you have these challenges.
Mm-hmm. Yeah, and one of the main points is that a lot of these systems have quite a number of devices. You mentioned 50 devices, but you're talking about hundreds, thousands of devices deployed in some of these locations. Say a smart city, if it were streetlights, for example, try to count the number of streetlights in your city, right?
Yeah. So when I said 50 is 50 types of devices, of course, per type, you can have millions of devices of the same type.
Right.
Yeah.
Yeah.
Right.
Yeah, very cool. And this framework is available on GitHub.
Yeah.
We'll provide the link later on our Twitter channel, and but it's available on GitHub at AWS-samples slash AWS-STF. And so if you wanted to have a look at that, yeah, tell us a little bit more about this open source project. What other aspects are there for this?
Yeah. So we mentioned data producers and data consumers. So basically, there are three main components in the smart territory framework. You have data producers. I will explain a little bit more how they are designed. Data consumers, I will also explain how they are designed. And in the middle, you have what is called STF. So STF is the acronym of the Smart Territory Framework. You have the STF core platform, right?
Yeah.
So STF core, there are two components within the STF core, two modules. One is actually an open source technology that is provided by the FiWare community. So few words about FiWare. When we started to design this framework, we looked at the different ecosystems. We looked at what were available in the market in terms of standards, in terms of technologies that could help our customers to aggregate this data, make their platform interoperable. And we found out this this ecosystem with a strong momentum, gathering plus 500 companies, including Red Hat, Atos, NEC, and also having more than 300 territories that have implemented their technologies. So we looked at what they are providing, and they are providing basically mainly because there are lots of components that they provide, but we are interested in mainly two things: the standards, the open standards that that they promote, and also the open source technology, the main open source technology that they provide, that is called the context broker. And so the STF core uses the context broker and the standards they use. And basically the context broker, you can see it like a kind of a database to store all your information. And the way you store it, the way you publish your information or your request information is standardized. So it's standards API plus a standards information model. And the context broker provides you this capability to store your information, request your information, but also advanced capabilities like geoqueries, for example. And I just need to maybe explain how the information is stored. So the specification, the standard that is used in the STF is the NGSI standard, NGSI LD for its latest version, which is an extension of the JSON LD specification format. And so NGSI LD represents information as entities. So an entity is the representation of a physical object or a concept that exists in the physical world. To give you an example, let's say you have an occupancy sensor in a meeting room. The measurement of this occupancy sensor, so available or not, is an entity. The sensor itself is an entity. The meeting room itself is an entity, and each entity has properties. So if you take the example of the device, its properties would be the serial number, the manufacturer. The measurement would be status, available or free, and so on. The meeting room would be the floor in which it is, and so on. And the entities can have relationships with other entities because the information model, the NGSI information model, is a graph model. So you can, for example, know exactly in which meeting room the sensor is placed, and so on, right? So context broker store entities, and you can have, like I said, advanced capabilities like geoqueries. So you could say, I want to get all the entities that are 500 meters near these coordinates, and you would get all the entities that are 500 meters around. You could also create subscriptions, and that's an interesting feature because it enables to also decouple data producer and data consumers, but also decouple systems. So subscriptions is just a way to subscribe to an event based on specific condition or given a specific frequency. So you can say, I want to get all the entities of type, I don't know, air quality, and then you would get all the every 10 minutes, and you would get every 10 minutes these entities. Or you could say, I want to be notified when the temperature of any of these rooms are above or below, let's say, 15 degrees Celsius for European degrees. But you would get you would be notified with these specific entities. So that's what provide the context broker. We packaged these open source technologies using our container services like Fargate. And so this is something you can find on the GitHub. And we augmented the context broker with another component that is called the STF IoT. And that's this component that provides you the IoT data lake, the digital twin capabilities, the central registry, and so on. And these two components, they are packaged into a CDK application. So CDK is Cloud Development Kit, which is also an open source framework to provision your cloud resources using popular programming languages like Python, Java, or JavaScript. So it means that you can, for example, if you want to create a database, you can just type some code to create this database. So you can have this infrastructure as an application. And this is what we provide in the STF repo on GitHub is actually a catalog, including the STF core of CDK application that you can deploy. And so this core platform, you can deploy this core framework, the core component, you can deploy it with only 3 lines of command, and you have these capabilities that are mentioned that are already available and scalable. And then you just need to plug your data producers and data consumers. And so what is a data producer? It's a process that gets data from a source, raw data. So it can be from the sensor directly, from a legacy system, for an existing smart city platform. The data producer would transform the raw data into an NGSI entity. So it's about also standardizing the format and then push it to the STF core. That's it. That's the only, I'd say, process you need to do within a data producer: getting the data, transform the data, and publish it into the STF core. And for data consumers, they just need to consume the data, and they have multiple ways to consume the data. From the context broker with HTTP request, so get, post, and so on. They can also request the IoT data lake, and we have services like Athena, for example, that enables you to query using SQL the data lake to have access to the historical data, do some analytics. But you can also subscribe to the STF IoT via MQTT, because STF IoT leverages our device shadows feature. So at the moment there is a change in any entity, you could subscribe to these changes and trigger any scenario. And or for example, you could create this a mobile application for smart parking. That's a concrete example. And then you could have in real time in the application the changes of the parking spot without the need to query anything.
So there's a relationship with the Smart Territory Framework, STF, with the existing IoT services on AWS. So AWS IoT Core and the Smart Territory Framework work together, essentially.
Yeah, it uses, so the STF IoT module uses shadows, so device shadows. It's basically built on top of device shadows. And it also, when I mentioned the registry, it uses actually the things registry and leverages all the features of device management, like a things group and so on. So when you create, for example, things, you can associate within the STF IoT different entities to a thing, which means that, let's say you have this thing concept, which is an abstract view of a device, for example. And if you create a thing for this air quality sensor, you can have a shadow, you can have an entity that represents the device itself with its attribute like the serial number and so on, that is associated to this thing through the name device shadows. But you can also have the measurement itself associated to the same thing, which means that with only one query to the shadows, you can get all the information of the device, but also the data, the measurements from this device, right? You are not only able to get the information about the device itself, but also about all the associated entities to this device, including the measurements. So that's what provides the STF IoT. And of course, IoT rules as well to route the messages to the context broker, because everything that goes through the STF IoT module is replicated into the context broker, and then it's batched and stored in the IoT data lake, which is actually based on Amazon S3.
And so you could use this not only for really like sensor data and analytics, but also even for device management. So there's kind of like multiple, maybe planes for the for the data in this case, right?
Yeah, exactly. Because like I said, you have this property stored in name device shadow. So let's take the example of your fleet of devices. You have devices all over the place, using different technologies, some connecting through MQTT, some connecting through LoRaWAN, and so on. And one property of this model that you use for representing the device has this property battery level. And you could have, for example, a specific rule or create even a subscription that says at the moment the battery level is below, I would say 25%.
Mm-hmm.
I trigger some scenario, right? Or I put them in a specific list to go and change the battery and so on. So you can do actually device management also with this core framework.
Mm-hmm. Mm-hmm. That's great. That's really great. Hey, why don't we go to Nenad or Alina or Syed with any comments or questions for Ali?
Actually, I have a question. I wanted to ask about enrichment and further transformation of the data. So let's imagine you have multiple producers, you get all the data, you store it in a data lake. What happens if you'd want to augment that data and you want to integrate, for example, with other third-party systems or internal systems? Would those systems need to become producers as well, or to be registered as producers?
Yeah, you can see it as a kind of a fractal solution. So your data producers produce standardized data into your core platform, right? And from your core platform, from your perspective, they are all data producers. Let's say now you work with another organization. Even if you have the framework on your side, they just see you as a data producer. So you can aggregate all these platforms together, federate all these framework, all these platforms together to actually enrich the data. And it will be very easy to aggregate because as it's based on standards, it's easy to integrate, right? They don't have to do the work for every type of sensors because on your side, at the moment, you have ingested all, for example, the air quality data. Then if they want to enrich air quality data on their side with traffic management, for example, or for traffic monitoring or for waste management, let's take a concrete example. They want to aggregate traffic monitoring data with their waste management solution. So they would just see you as a data producer for traffic monitoring data. But in that case, they don't need to transform anything because you would provide them this data coming from heterogeneous sources. You would provide them this data already standardized and easy to consume.
And just one question about this standardization. How do you ensure that the data is standard? Is there like some sort of standard data model that is followed?
Yeah, that's actually a good question because I forgot to talk about the data models we use. So NGSI, the specification provides you two, I would say, sub-specification. The first one is a standardized API. So the way you publish the data, the way you request the data, so it's a REST API and it's standardized, right? And the second specification it provides is about the information model. That's what I described as entities. So entities has a specific format with some properties, relationships, and so on. And on top of this information model, the STF leverages an initiative called Smart Data Models that has been also developed by the FIRE Foundation, TM Forum, the Open and Agile Smart Cities Network, and I don't remember which organization is the TM Forum, I think. And so they provide, and it's also available on internet, on GitHub. They provide this initiative called Smart Data Models with plus 900 data models in 12 different domains. So for smart cities, there are data models for energy, for manufacturing, for buildings, there are data models, which means that, for example, if you want to represent an indoor air quality measurement, there is a data model for that. If you want to represent a device, there is a data model for that. And by the way, this is the data model we use for the device management within the STF. We use the data model device. So we leverage this smart data model initiative, which is open and collaborative, which means that if you identify that there are any gaps or any missing data model or property, you can collaborate, you can submit your data model or your improvement.
So sticking with the data model part and sticking with NGSI model, from the NGSI perspective, we have ETSI from a European side. Is this model NGSI is widely accepted across the continent, or they have different standard of variation?
No, so if you, for example, take about the reach, the impact of this ecosystem of the Fireware Foundation community, you have implementations using NGSI in Japan, in India. For example, the IODX, which is the India Urban Data Exchange, which is a kind of organization that that provides the strategy for all the cities in India. They also have adopted these standards, so the NGSI specification. You have also a very good momentum, of course, in Europe, in Middle East. You have, for example, the city of Al Medina in the Kingdom of Saudi Arabia, who's become a platinum member. So that's the highest level of membership within the Fire Foundation. And they also have their platform that uses these standards. You have also in Latin America, capital like Montevideo that using these standards. So it's worldwide. You have this body of standardization called ETSI, which is a European one, but the use of NGSI is global, and there will be probably other organization of standardization in other continents that might in the future also adopt and specify it. Integrate it as a specification.
Great. So I guess the one question that comes around from NGSI perspective, I had a look at NGSI. I also saw some data models on the Fireware website where we were talking about NGSI v2, and I also looked at JSON LD. Do we have actually any overlapping factors here?
Okay, so NGSI v2 is the former version, right? And NGSI LD has introduced the LDs for linked data. So NGSI v2 is JSON, a JSON document, and NGSI LD is a JSON LD document. So you have this concept of context that enables you. That's why the LD is for linked data, because the way you name temperature, for example, might be different from the way I name temperature. You can say temperature with capital T. I could say, oh, temperature with lowercase t, or temp for me, anything, right? So if you want to have the full URI, the kind of the unique way of the long version of the property temperature, you would expand the property temperature based on the context that is provided as part of the JSON LD document. So if you look at JSON LD document, so you would see that there is this property called context that provides a link in which you have, or a link or a context, a document that provides you the definition of the short-term properties. So instead of using the full URI name, you can use then short-term properties, and if you want to transform it, you can use the context as well. So that's why you see NGSI v2 and NGSI LG. So you could deploy the smart territory framework using NGSI v2 with some adjustments, but we always recommend to use NGSI LG because that's the latest version, and it provides more
Awesome.
interoperability.
Great. Thanks.
So that really helps with normalization too. Once you
Yeah.
get to the back end of your infrastructure, yeah. Okay.
Yeah, because you will have multiple applications that would consume this data, and even for translation, that can also help you. Let's say you have properties that are in English and you want them in Japanese. You can provide your own context at the moment you consume the data, and you would say, okay, this short term for me within my language is that, and you would get then this translation done. So that's examples of how you could use the context. There are actually some tutorials that are interesting to read on I think it's on the Fireware website, or you could find them if you go visit their website, talking about what is the context and how to use it.
Oh, that'd be cool. We should provide those later after the discussion here. We can provide those links if you want to share those.
Maybe what I'm really curious about is if you could give us an example and walk us through a little bit, or a use case and walk us through how the framework works. This would be great.
Yeah, there is actually a video on YouTube that shows how to build a digital twin of a classroom using the smart territory framework and another IoT service, AWS IoT service, that is TwinMaker. So in that case, for example, you first start with the core platform, right? That's the core component. You deploy it, like I said, using CDK. So few lines of command, and you have the foundations for your platform. And then in that case, we wanted to get air quality indoor measurements from LoRaWAN sensors. So we built a data producer, and the stack is available as well on the STF catalog if you just want to deploy, but I will explain how we built it. So you create a data producers that get the data from the LoRaWAN sensor using AWS IoT Core for LoRaWAN, that transform the raw payload. In that case, it's bytes. You create this entity. In that case, we use the data model called indoor environment observed. And then once the entity is done, you publish the entity into the STF core. So the component, the input is in SQSQ. So once on the data producer side, once your entity is standardized, you publish into the STF core queue, and then it is stored on the context broker, on the data lake, and so on, right? And on the consumer side, we use multiple consumers. Actually, we in a chain of multiple data consumers. The first one was using Athena to query the data lake using SQL, like I said, queries. And then we use TwinMaker, and we created, so TwinMaker is a service that makes it easier to create digital twins. And you don't need to you can use your existing data source. And in that case, we used the IoT data lake as the data source. And so TwinMaker, we created a scene with a 3D model of the classroom. And then we tagged some piece of the 3D model. So a tag is just the association of a part of the scene with an entity or with a property from an entity. So just to see the temperature, the humidity, and so on. And so then the TwinMaker is connected to the data source via Athena, via what is called a component. So you create a component within TwinMaker to fetch the data from your data source. That's what we've done. And then the last piece was just visualization of the twin maker scene and all the data within Grafana. So that explains how you can basically build an end-to-end solution with different components. You could replace any of these components, any of these data producer with any other data producer. And let's say now I want not only to measure the air quality, but I want to add the consumption of the electricity consumption of the building or of the classroom. Then all the steps about deploying the core and so on, I don't need to do it. I just need to create a data producer that would get the electricity consumption, use the data, the according data model, and then push it to the STF core. And on the consumer side, whether I use the same dashboard and then I just add this new view or this new data within my dashboard, or I can create another data consumer.
That's really neat. So in the visual model, you could even show where these sensors are, that kind of thing. Is that right?
Yeah, because I won't be too technical and too much in the details, but with the STF, there is a mechanism that when you provision devices, you provide the location of the device, and then every measurement from this device would come because there is a mechanism that will enrich the in-flight message with its location without any API call. Because what you see often with IoT devices, they don't send with the payload, they don't send the location, right? And if you use
Right.
if you use parking lot sensors, for example, you would have parking lot sensors deployed in your city, and they would only send you the status. I'm available, I'm occupied, and so on. Then for each of these message, you would have to call via an API the registry to say, oh, actually, where is this device that just sent me its status? With the
Right.
STF, you don't need this. You would receive at the moment, you would receive the data enriched already. So you can just plug, for example, a mobile application or any web application, and you would have in real time the status of every parking spot with their location. So you can create a map and see where are the parking spots available and so on in real time.
So it combines those data elements. That's really great. Yeah, that's often missing is data about the thing, not just the data that the thing is producing, right?
Yeah, and most of the time you need, like you said, the data about the thing, because if you want to, like you said, just create a map and see where are the assets, where are the parking spots, where are the sensors, then you need the location. And if you want, for example, to know the battery level, whether it's not always sent with the data, so you can get it from the device data model as well. So you have multiple capabilities using the STF core.
Awesome.
And it is explained in the GitHub much better than what I'm doing right now. So if you want to see how it is designed, what are the design considerations, because there are naming conventions, there are few explanations in the GitHub.
That's cool. Yeah. Hey, it looks like we have a listener who wants to have a comment or question. Axel is joining us, and let's see. Let's give him the mic here, if I can do that. Okay. Hey, Axel, you're on.
Oh, great. Can you hear me now?
Yeah,
great.
We can hear
awesome.
you.
Thank you. Yeah, I was just wondering, when you're talking about breaking up data silos and having a model that allows interoperability between organizations and so on, you always get the question of.
I don't know, Dan, if you can hear Axel, but I don't hear anything.
Oh, you don't? Okay. Yeah, I hear Axel just fine.
Yeah. We hear
Try
you.
try again.
Okay,
Try
yeah,
again,
okay, I'll try again. When you try to break up data silos and enable interoperability between organizations and so on, there is usually the question about both the authenticity of data and confidentiality, leading to things like signed, like cryptographically signed data, encrypted data, and authorization models of like who's able or who is allowed to send what. And keep this information beyond just the 2 points in transmission. Does the framework support anything along those lines?
Okay, so now I hear it. So everything I presented today was more in a scenario in which you control the data producers, data consumers. That's for your own platform, right?
Yeah.
What you mentioned is more for data sharing, data spaces, to use the right terminology. So in that case, of course, you need to have these rules to make sure that the data you produce is or the data you get from this data space is secured, with the right level of integrity and so on. This is not supported is not the terms because some data spaces might use actually the same um, protocols and standards we use. But the smart territory framework, as you see it in the GitHub, doesn't provide the components for this yet.
Okay, thank you.
Okay, yeah, that's an interesting point. When you talk about protocols, I guess the flexibility of the smart territory framework is that it's in some ways protocol independent, right? You mentioned LoRaWAN, but it could be other kinds of connectivity or other kinds of protocols sending the data, right?
Yeah, it's technology agnostic on that side. So you can consume the way you want, you can produce the way you want. The important piece is that it's standardized at the core level. And then when you share the data, then whether you need to transform the data or use some mechanism to make sure that there is this at the level of the security requirement of your data space. But then this is a component that you would add. And in that case, you just consider this sharing platform as a data consumer on your side, right? This is just another data producer. And whether or not you need to adjust to this data producer, this is a process that can be independent from the core.
Yeah, I was about to mention this. So the general idea is like you have this deploys on your platform and you are operating this, and then you have different data producers and data consumers. But then once you want to expose this to a third party or whatever, then you would have to use the starter mechanisms. And if they have this deployed, as well, then this you can actually become a data producer or data consumer from their perspective, right? But then you would need to again apply some kind of security best practices that in general you would depending on the platform and so forth, right? Is that good assumption?
Yeah, exactly. And even for the context broker, they actually provide some example of what is called a context broker federation, which means that you could enrich some data that are in your context broker with data that are in another context broker from another organization via this federated context broker. So there is a mechanism to do it. It's already part of the context broker design. So this is not something we highlight in the STF, but all the capabilities of the context broker, because we use the context broker, are available in the STF.
So if somebody wanted to get started with STF, where's the best place to get started? Just go to the GitHub repo and look at some examples, or what would you recommend?
Yeah, so the GitHub repo, there is a main GitHub repo that provides a catalog with example of data producers, data consumers, and their STF code. There are also links to videos that might be interesting to watch to understand the why we designed it this way. Also, what are the more information about the specification, more information about the design of each component. And then there is this video that I mentioned about the digital twin in a classroom that is very interesting because I start from scratch and I create the end-to-end solution in 20 minutes. And for each component, I provide a link to a stack to deploy it. So if you watch the video, you can reproduce the same just by watching the video. So there is nothing that is hidden, that I'm not showing. Every steps are described. And then in the description, video description, you find the links for every stacks that are used, and you can reproduce it on your side. So I think that's a good start to deploy, test, create some data producers, data consumers. And this is an iterative process, right? We make it better over time. This is something that is open source. So each time we have a new use case with the customer, we try also to share this work we do with customers. We try to provide it to the community so they don't need to reinvent the wheel each time, right? But this is something we do over time. We provide new capabilities, new features, even for example, for the device management, we released a version a few months ago with more capabilities for managing your IoT devices.
Cool. So this classroom, I imagine you can even add data producers to that. Try to figure out how well are the kids learning, right?
Exactly. So yeah. So the example I gave about the electricity consumption, that can be one. So you could say, oh, actually, I want to, because what they realized. So I worked with customers in the suburb of Paris for this use case. And what they realized is that, okay, the air quality, the temperature, humidity, and CO2 level of your classrooms, but you can also use this data for improving the efficiency of your building, because they realize that during the weekend, sometimes there are windows that are left open, so they heat for nothing. And you can see it because it's just about creating a subscription. At the moment you see the level of the temperature below, I would say 16 degrees Celsius, then you know that there is something that is not right, normal. So you can send someone, check, exactly which classroom and so on. So you can use also this data for other use cases and for other purposes.
Fantastic. Let's see. Does anyone have anything else for Ali before we wind down here? We are rapidly approaching the top of the hour. The time has flown by. I'm actually surprised looking at the clock here. But anything else from anyone? Okay, great. Any final thoughts, Ali, before we end today?
So it's open source. It's based on open standards, and it's collaborative. So if you think that there are things that we could improve, feel free to reach out, contribute. I'm looking forward to seeing how the community find creative ways to improve the framework and also use it. It's yours, and you can build we have partners that are building their own solution platform on top of it. So this is also something that you can use as a framework to build your own platform. You don't need even to mention that you use the STF, but you can use it as a starting point for your platform or for your solutions. So feel free.
Great.
It's available on GitHub.
Great. So we've been talking with Ali Benfattoum about the Smart Territory Framework, which is applicable to smart cities, smart buildings, that sort of thing. Thanks a lot for your time today, Ali. Really appreciate great discussion, great info. Thanks so much.
Thank you for the invitation.
All right. Thanks everybody else. We'll be back next week and with more discussion around IoT. All right. Cheers.
Cheers.
Bye-bye.
Cheers.
Cheers.
Bye.
Thank you.
Bye.